Okay, so in this video, we're going to be doing long division. Specifically, we're going to be doing ones without remainders and then with remainders. And both of those types of problems are going to use these three steps here. So we have dividing, subtracting, and then dropping a number. I'm going to highlight what these are as we go throughout the problems, but these three steps repeat multiple times throughout long division. So they're just good to keep track of, especially when you're doing them on a test or you're doing them as practice problems. Before we get started on the problems, I want to list a bunch of components that are within long division that you need to keep track of that I'll use throughout this video. So the first one would be the divisor. The divisor is whatever number we're using to divide. So divisor is the number out front here. Our dividend, which is the number being divided, is the one that's under our sign here. So our dividend is the one that's below that sign. Our quotient is actually our solution, so that's the number up top here. And then in the problems that do have this, there's also remainders, which are the amount that's left over after all numbers have been divided. So this is our remainder number. And that should make sense because it's typically labeled with this R. That's very common. Throughout grade school, they're going to have you list an R at the end, just as short form for the remainder. And that's just to give them the indication that there is some amount that is left over after all division has been done. Okay, so we have problem 1 here. And let's, just off to the side here, I wrote all 3 steps we need. So dividing, subtracting, and dropping. And I'm going to mention them as I go along. So we are following along these same steps as we go. So in the first case, we said number 1 is to divide. Well, what are we dividing? We're going to be actually dividing the first number of the dividend by the divisor, which is number 11. And so when we do that, we're saying 6 divided by 11 is going to give us something less than 1. So we actually can just write 0 as our first number below and 0 above in our solution or in the quotient. Then our second step is to subtract. We subtract 6 minus 0 is just 6. And then we drop, which is step number 3, we drop our 2 number or the number next to the 6. And then that's going to be our next line here. Now we repeat the same steps. We've done all 3 steps. We divided, which was 6 divided by the 11, which gave us 0. We subtracted, which was 6 minus 0. And then we dropped the number next to the 6, which is number 2. Now we have to repeat the same steps again. So now we're back to division. 62 divided by 11 is going to give us, so let's write this over here. 62 divided by 11 is equal to 5.63. That's not quite 6, so all we're going to write in our quotient is 5. And then now we have to say, what's 5 times 11 is going to be our next number here. So that's 55, because 5 times 11 is 55. We go to step 2, which is subtract. When we subtract the 2, that's 7. And then now we got to drop the next digit, which is 7. But did you see how we did all 3 steps? We divided, which was 62 divided by 11. Then we subtracted, which was 62 minus 55. And then we dropped our final digit, which is 7. So now we go back to step 1 again and say, what's 77 divided by 11? Well, that's just 7, and we write that in our quotient here up top. And then what's 11 times our last digit, 7? That's just 77. And then when we subtract them, we get a 0, which means we have a 0 remainder, and we could actually write that above here typically too, because they'll look for that in our quotient line where we have our final solution. So you could always double check this in your calculator and just confirm that 11 times 57 is equal to 627. But yeah, at the end, you would do that in your calculator just to make sure you got the right solution and that you didn't have some form of a remainder. Let's repeat these same steps again for another one with no remainder. We start by dividing, so we're going to say 3 divided by 6. Well, that's actually less than 1, so we're going to write 0 again, and then 0 in our quotient. Step 2 is to subtract, so we're going to subtract 3 minus 0 is 3. We're going to drop the digit next to the 3. And then now we say, Well, we're going to go back to step 1 and say 31 divided by 6 is going to give us 5.16. And that's not quite 6 and it's not quite 5, so we're just going to write exactly 5 here. So now we have to go, what's 6 times 5? And that's going to give us 30. Step 2 is to subtract, which 31 minus 30 is just 1. And then step 3 is drop the digits. So we're going to drop. Now we go, what's 12 divided by 6? And that's just going to be exactly 2. We write 2 up in our quotient for our solution. And then we have to say, what's 6 times 2? That's going to give us 12. And then when we subtract, we get a 0 remainder. And then yet again, in our calculator afterwards, we could go, what's 6 times 52? Well, that should just give us 312, exactly our solution back. And like I was saying before, a lot of the times if you have a 0 remainder, they'll actually get you to write above in your quotient just to show that you got a 0 remainder and you acknowledge that remainder. Okay, so now for the trickiest of them all. This is going to involve the most amount of those repeats of steps. So the dividing, the subtracting, and the dropping. We're going to have to repeat that the most here, and it's just because it's the biggest number, but that's the only difference. So don't get intimidated by big numbers. It just means you have to repeat the 3 steps more often. So let's restart with step 1 here. We'll divide. 6 divided by 42. Well, that's just going to give us a 0 yet again because it's less than 1. And so now we're going to say 6 minus 0. Well, 6 minus 0 is just 6. We drop the 0. And then now we go back to step 1, divide. 60 divided by 42. Well, that's actually just going to give us 1.42. So we know that that's just roughly about 1. And then now we have to multiply to get our next line here. So we go 42 times 1. That's just going to give us 42. Step 2 is to subtract. So 60 minus 42, that's going to give us 18. Then step 3 is to drop the number. So we're going to drop our 4 here. And then we have to go back to step 1 and divide. 184 divided by 42. That's going to give us 4.38. We're going to write 4 up here. Then we have to multiply 42 times our 4. 42 times 4 is just going to give us 168. Then we got to subtract the 2. When we subtract the 2, we're going to get 16. Then we got to lower our digit here. So our last digit, which is 8. 168 divided by 42 is exactly going to give us 4. So 168 divided by 4 just gives us 4. And thus when we go 42 times our 4, which is our last digit, we're going to get 168 back. We subtract the 2 and we get a 0 remainder. And then we would want to write that in the top again. And so what we can do here is we can say yet again, what's 42 times 144? Well, this should just give us back our 6048. And that's how we would confirm it. We just go to our calculator in the end and type that in just to make sure, especially with a 0 remainder like this. Okay, so now we're going to deal with problems that involve having a remainder at the end. So it means they don't perfectly divide the numbers. The dividend isn't completely perfectly divided by our divisor. So let's repeat these same steps. Like I said, they're used for both. The divide, the subtract, and the drop are used in both cases. We say 7 divided by 16, that's less than 0 or less than 1, so we get a 0 for our first 2. We're going to subtract, so 7 minus 0 is just 7. Then we drop our 1. And then now we need to go 71 divided by 16. Well, that's just going to give us 4.43. So we're going to write 4 in our quotient. Now we have to say, what's 16 times 4? 16 times 4 is actually just going to give us 64. When we subtract these two, we're actually going to be given a 6. Or a 7. Then we're going to drop our 6 down. We say 76 divided by 16. That's going to be equal to 4.75, which isn't quite 5, so we're just going to write 4 up. Now we have to do the same thing yet again. We do 16 times 4, or our last digit of the quotient. We get 64 back again because it's the same thing we multiplied last time. Now we go 76 subtract 64, which is going to give us 12. And the reason we're going to call this our remainder now is that 12 divided by 16 is less than 1 again. So it's over and above what we had. So now we call this last digit here our remainder. And yet again, we can write it in the top as 12r, right along the line of our quotient. So we know that 16, if we were to double check this in our calculator, we go 16 times 44. So our divisor times our quotient. And then with this one, that's going to give us 704. And thus the difference to make up the dividend would be plus 12, which is our remainder, right? So we see that our remainder is that amount that we need to get to our 716. And thus we've confirmed that our remainder makes sense for this. Okay, so now we have another one with a remainder. We start by saying, what's 1 divided by 17? Well, we're going to get a 0 for both slots again. This is very common. It's pretty much going to happen every time. We're going to say 1 minus 0 is just 1. We drop the 4. And then we say, what's 14 divided by 17? Well, we're going to get another 0 because it's still less than 1. And then we say, we have to subtract these two. So if a 0 happens again, then it's 14 minus 0, which is 14. We drop the next 4, so we get 144. And then 17 divided by 144 divided by 17 is actually just going to give us 8.47. So we're going to write an 8 in our quotient. And then now to get the number that we subtract by, it's 17 times 8, which 17 times 8 is just going to give us 136. When we subtract these two numbers here, we're going to be left with 8. We have to drop our last digit, which is this 0. And then we say 80 divided by our 17. 80 divided by 17 is 4.70. So we're going to write a 4 in our quotient. And then we have to say, what is the number we subtract by? Well, that's just 17 times our 4. 17 times 4 is going to be equal to 68. And thus we get a 12 remainder here. Because 12 can't be divided by 17. It's less than 1. So we know anytime we get a divisor less than 1 and we're at this stage, and we have no more numbers to drop, we know that has to be our remainder. And to confirm too, we say 17, which is our divisor, times our quotient of 84. That's going to be equal to 1,428. And thus our remainder, if we add this on to the end, plus 12, we're going to get our dividend, which is 1440. And thus we've confirmed our solution is correct with that remainder of 12. And then for our last one with the remainder, it looks really intimidating. We got huge numbers like we do in some of the previous problems, but we're just going to take it step by step and repeat those same 3 steps. So beginning, we divide. 3 divided by 31, that's less than 1. So we have a 0 here and a 0 here. Then we subtract, so 3 minus 0 is just 3. We drop the next available digit, which is 4. 34 divided by 31, well, let's write that off to the side. 34 divided by 31 is just equal to 1.09. So we're going to put a 1 in our quotient. 31 times 1 to get our next digit we subtract by, that's just going to give us 31 back. We're going to subtract, which gives us 3, and then take our next available digit, which is 4. 34 divided by 31, again, is going to give us 1.09. We have this same situation, so another 1 goes in the top. Yet again, we're going to go 31 times our next number here. So 31 again. We subtract the 2, which is going to give us 3, and we drop the next available digit. And then 32 divided by 31, well, that's going to give us just something slightly, I guess I should put roughly here, just over 1.0. So it's going to be 1.0 something. And that's just going to be just over 1, so we put another 1 in our quotient. And then so now when we multiply this back, we're going to get 31, or I should say when we multiply 31 by the last one, we get 31 as our drop. We subtract the 2, which leaves us with 1. And then we consider this our remainder because 1 divided by 31 is going to give us something less than 1. So we have a remainder here, which is a 1 remainder here. So our solution is 111 with a 1 remainder. And then to confirm this, we would say 31 times 111 or 111 to give us 3,441. If we add our remainder to the end here, so plus 1, that's going to give us our dividend, which is 3,442. So we know we've confirmed our solution with a 1 remainder at the end. All right, and then returning just back to this screen that we used to explain our terminology, what do we consider the answer when we do long division? The answer is actually just everything that's in this top row that's considered part of the quotient. So what I mean by that is everything that we finish with up in this top part here, along this quotient row, that's considered the answer there. So depending on your teacher, they may get you to write it below your work. They may get you to write it just here and then box it like we did. Like they would say that this type of step is correct. It just depends on who your teacher is, but we do know that as long as you write, so you'll have both the remainder in the bottom when you're done. If you want to take that up and put it right next to your quotient, which is your solution, so if you want to put it next to this number here, that's going to help your teacher know exactly what you're talking about and make sure all your information and your final solution are together.